Okay. All right. Uh, Thanks for tuning in. I'm Sameer. Thanks to the organizing team for giving me this opportunity to present at this event. I'm actually going to let's say present a topic on IoT and edge computing, pushing value to the edge. Just to give you my background, I'm Sameer. I'm an enterprise architect within the digital group of Evident. I primarily provide architecture and technology leadership for strategic accounts and also drive the solutioning for large deals in Evident. So here we start. Here we go. So I'll let's say move to the next slide now. So this is basically what I want to walk through and probably discuss in this session. It actually would basically start with understanding the device proliferation and the volumes that we basically uh, are 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 required to actually manage as part of our IoT ecosystem. Then what are the typical customer challenges that we have uh, while deploying and working on IoT platforms and IoT solutions. Then the next is basically a typical IoT platform at what exactly it constitutes in terms of its solution building blocks and services and components. Then we go to the edge, what the edge computing, and then move to smart edge and what exactly constitutes a smart edge and why do we need, what are the key drivers behind the smart edge solutions that we have as part of the IoT platforms. And then I would like to walk you through also the IoT ecosystem of Azure hyperscaler, uh, probably discussing about the various services and solutions that we have in there. So yeah, we start. So I think in terms of the volume, right? 50% of the industrial enterprises are the ones that use the IoT platform to improve the efficiencies and the factory operations, which is up from, so I think it's 50% is typically the projected number in 2025, which will be up from 10%, which was there in 2022. Uh, we have about we have about we had about 20.4 billion connected devices in 2020, which would actually go to about 8.5 billion. Rather, it will go about 55.7 billion connected devices worldwide in 2025. So that's the projected numbers that we have in terms of the volumes and the scales that IoT platforms operate at. So this is basically the view on that. Then, what are the typical customer challenges that we have in today's IoT platform? So, it actually includes various things. So, to start with, there's lack of analytics-driven insights to make real-time business critical decisions, and that happens because the entire IoT ecosystem consists of the endpoints and the IoT hubs and the gateways, which actually then, let's say, uh, uh, which actually consolidates the data and then sends that information back to the central applications, and then from there on it again is, let's say, massaged and probably decisions are taken, and then the the information and the data is sent back to the endpoints, and that's basically, it's like a round trip. So it basically, the applications and the solutions that were built earlier who basically had this uh, challenge of latency and round trip, which basically constitutes one of the key challenges. Then we have inability to make real time decisions. So I think what it says is, you the earlier generation platforms, they basically didn't have the computing power, the processing power, and the solution to actually make decisions there at the edge itself. So I think it was basically just static devices which would basically get the data from your sensors and actuators and, let's say, the factory lines, and then basically just send it over the network to the central application. So there was no ability to make real time decisions at the edge. high cost, lack of resources, and no expertise to manage complexity. So, as I said, in terms of the scale that we just saw, billions of devices connected, we basically had a complex ecosystem of edge devices, your nodes, your gateways, your central system, which would basically host and store your data, and then you basically had your application. So the entire thing was so complex that it basically was very expensive. At the same time, there weren't resources to manage it. So if you have an ecosystem consists of thousands of devices, right, be it your fleet of trucks, or be it your, let's say, bank network, or be it your factory line, there were so many different endpoints and nodes that had to be interlinked, connected, and at the same time monitored, that it became difficult for the entire team to manage it, unless there were automation, there was the right set of devices in place to make sure that the complexities are taken care of as part of the solution. And then the need for business continuity, regulatory compliance, and data sovereignty as well. So and I think this is something that comes up because as you have several devices that would be distributed across your network at various locations, right, sending that data over the wire, over the network, is not always an advisable option, because there could be they are actually sort of making it vulnerable for the attackers and the hackers to basically get access to it and probably use it for malicious intent. So these were the key challenges then. So I move on to the next slide. So this is what the IoT platform constitutes. So these are the three key pillars or three main elements of the IoT platform. They are things, they are edge devices, and they are the gateways, right? Things being the sensors and the actuators and your and all your robotics in your factory line. The edge devices being your, so the edge devices is a generic term that is leveraged here, but I think edge is what they call it. The next generation of devices are the smart edge, because they can actually make decisions on the fly, not requiring the core central applications to actually sort of drive them. And then the gateways, of course, so basically the hubs that would actually uh, 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 are the ones that are integrated with your devices and sensors, and basically do the various elements of protocol conversion and security and policies, etc. And then comes the IoT platform itself. That's where you have your data lake, data storage. That's where you run your AI machine learning models. That's where you actually have the device management and data collection, which basically articulates and, let's say, consolidates all the data that is coming in and streaming in from various endpoints into a central data lake. And then you basically work on the various AIML modeling and algorithms to make sure that you have the right feature engineering done and the right decisions taken. And then the third pillar being the IoT and the enterprise applications, which are basically nothing but the vertical applications that leverage that data to drive various use cases or various scenarios on that. So these are the three, let's say, key pillars of that IoT platform. Uh, so if we move on to the next slide, right, this actually is a deep dive of the earlier slide. It actually tells you about what the end-to-end value chain of the platform looks like. So it starts with the devices and the sensors, which actually are nothing but uh, they actually discover, analyze data embedded in the objects, and gather information such as temperatures, humidity, and various parameters that gets ingested from the sensor and the devices. So these are your sensors and the devices which actually sort of capture the data, which actually then ingest that data into the streaming, let's say, network, to send it to the central applications. The next being the edge computing, which is basically the connectivity part, which constitutes of either your Wi-Fi networks or your cellular networks or your LAN. It really depends on what exactly is the use case that you have provisioned on for the IoT platform, and basis that all these various pros and cons are evaluated to understand what is the best connectivity option. If you're actually sort of leveraging, let's say, an audio video to be let's say transmitted on this network, I'm sure you will probably not you'll need more bandwidth, you'll need more power, and accordingly you'll have the right networks. Networks needs to be provisioned to make sure that there's no loss of data and signal. And then at the central is the IoT platform. So there's a there's a gamut of things or a gamut of choices available in terms of what these platform constitutes. So we have platforms from Mindsphere, we have platforms from PTC, we have platforms from various hyperscalers as well, be it Azure, be it Google, be it AWS. And I think some of these platforms, I think, or typically what happens is when you're actually, let's say, working with a customer, you'll probably need to analyze the overall roadmap, overall business goals and objectives to arrive at what is a platform that suits based on various functional and non-functional aspects. So these are the various choices that you'll have as part of the platform. And then you have the business services, right, which would basically be the user scenarios or the business scenarios that actually run on top of it, be it your truck fleet management, be it your rig management, rig solution, oil rig solution, be it your factory setup. And those are the ones that probably be based on the various, let's say, customer or overall roadmap that and objectives that you'll be working on. So this is the end-to-end value chain for the IoT platform. The next is the IoT platform, which actually provides with the integration elements of various endpoints, various solutions that are there on the platform. So if you see on the left side, right, those are the IoT endpoints. These are the solutions that are basically your sensors and your devices and your things, which basically ingest the data into the IoT edge platform, which, let's say, gathers the data, and then it makes sure that the data is massaged and is in the right format, which then ingests it onto the IoT cloud platform, which is your core platform, which stores your data in some form of a data lake. So if you see, the integration lines are actually going from right to left and left to right as well. One left to right are the ones that actually constitutes the data ingestion or the data, let's say, processing pipeline that they have, and the ones that are from right to left are the ones that actually are device management. So when you have several devices on your network, it can be rolling out of patches, rolling out your security updates, rolling out of your policies. It can actually also be making sure that you have elements to direct the endpoints, the smart devices, to, let's say, accomplish things, to make sure that they have the right KRAs and the KPIs driven through the factory line, etc. So this is basically the next level of deep dive around the platform in terms of the integrations. So I think we move on to the next slide now. Right. So this is basically the solution architecture. If you see this, at the center is the data processing pipeline, which consists of ingestion, preparation, access, modeling, and then the presentation layer. So once the data is ingested from the IoT devices, once they come in from the IoT devices, smart devices, into the IoT gateway, into the edge solution, they get ingested into the data processing pipeline, which then goes through several stages of iteration. So one is cleansing the data. Second is where you have the data consolidated and aggregated in the right format, in the right semantics, and then there is also the modeling, which is AI, ML, machine learning algorithms that are actually run to make sure that we get the insights out of the various patterns that we can actually sort of analyze from the data. And then that is what is leveraged to drive your next level of business outcome, right? Be it sending it back to your factory setup, oil rigs, or your vehicles, and making sure that you drive the business outcome. So this is basically kind of a closed loop system where you'll basically have at the core, you'll have that data processing pipeline to make sure that you derive the insights and insights from the data that is getting ingested from the IoT devices and your edge devices. Now, this is an interesting slide, and it says, why do we really bring computing to the edge, right? So I think the key reason being, if you see, there's going to be a latency. So if you're not able to process that data right at the edge, there's going to be a latency, and the response is not going to be real time, because that data is then sent over the network from your edge device onto the IoT platform, which would typically be hosted on the cloud, on some of the hyperscalers, right? And then that application will then process that data, analyze the entire scenario, and then basically send the information back to your edge devices or your endpoints. And that's basically a kind of a round trip. So that's what exactly is the need for bringing computing to the edge. I think uh, it's not just sense and forward those that data from your sensors and devices, from edge to the central, but making sure that you actually process that data, analyze it, find a pattern around it, and make sure that you leverage that data to drive your business outcome. So this is basically what was the need to actually get it at the edge, computing at the edge, but also data exposure and privacy concerns, right? I think that's those two are the key ones. Uh, Consider that if you don't have processing at the edge, right, you can actually send that entire gamut of data, which can be good data and bad data, through the network. So it consumes your power, it consumes your bandwidth, it basically puts a lot of load onto the network, and at the same time, it's basically increasing the cost and the operational overhead, right? So to curtail that, that being another reason. So being latency, real time response, third being data exposure, and fourth being the privacy, right? So I think if you have that data sent over the network, I think it's vulnerable for the hackers and all the to actually get access to it, if it's going through multiple hops through your networks and IoT gateways and your hubs. So that's basically those were the key reasons why the computing was actually then brought to the edge, of the network, and arriving at the edge of the cloud computing and preparing the post cloud era, right? So I think the rise of edge computing was due to the fact that I just explained, and probably what and I think the key thing to note is by sending only the most important and least time sensitive data to the cloud and edge computing eases the burden on the cloud and the network. So that's how it reduces the cost. So that's probably what I just explained to you. That was the reason to bring computing to the edge. I think the interesting slide to note is I think there were various generations of these devices, the edge devices. The ones which would just just sense the data and forward it for the first generation devices, no processing done on that. The second generation of devices were basically somebody are the devices or were the devices which actually would process the data, run protocol conversions, run policies on top of it, and then had the element of processing built into it. So that's the second generation. The third generation of devices are the ones that these devices were the ones that actually had the processing power. It had the capacity to run the machine learning algorithms, AI/ML algorithms, and drive business decisions, drive business outcomes. And the fourth one are the ones which basically are the serverless ones, right? These are the ones that probably are low on their memory footprint and the high on CPU processing power, and that's probably where we are heading to, right? They need more processing power and low memory requirements so that it can be deployed. It doesn't have the operational overhead, and it can be deployed to the remotest of the locations. So these were the let's say various elements in terms of the various generation of devices. And I think this also constitutes to high volume. So I think if you see and as I also mentioned earlier, that if you want to transfer a computer vision using 4K 8K network, you'll probably need high processing power and making sure you have the right compute and storage to basically manage that. So those were the ones that probably required high volumes. It required ultra low latency as well. So autonomous vehicles, or let's say remote telesurgery. So while we were doing it from a central, let's say, system, it would still need to drive it from the edge, and that's probably where you need ultra low latency, making sure that you had the right processing power and capacity to drive it. And probably that's where the fourth generation of devices are, devices which are serverless, and they basically are high on the compute requirements and the processing requirements. So this is basically the market drivers. I think the next slide is the one that actually mentions about the different connectivities that are there as part of specifically considering the putting the edge, smart edge into the context, right? So there's southbound connectivity, which is basically connecting the devices and your sensors and your actuators onto the edge nodes. So I think the typical examples could be these kind of connectivities are established using protocols like Modbus and BarkNet and Sigfox, etc., which are the ones which are also proprietary. Some of them, yes. The northbound connectivity is the ones where you are actually connecting your platform to the hyperscalers, which would be streaming, which would be batch processing, which would be extract, transform, load kind of connectivity, right? The third being the swarm connectivity, which is nothing but connecting the smart edge nodes and the uh, uh, and the 3PP edge or central software as well. So using the standard protocols, which would be MQTT, which could be OPC, which could be zero MQ messaging. So these are the ones which are the industry standard protocols required to connect your edge devices and sensors and actuators onto the platform. And edge computing is finally the core, let's say, services that you need as part of the edge, or the smart edge, be it your processing, be it your time series, be it your storage. So I think the next slide actually depicts it in a pictorial format. So if you see, this is basically what it constitutes. A smart edge platform architecture constitutes what I just explained: the northbound connectivity, the southbound connectivity, which is basically here, the swarm connectivity, which is nothing but the standard protocols that you'll use to connect your devices and your uh, and your sensors and all the actuators. And then there's a edge computing as well, right, which actually constitutes your things around time series databases, time series computing, events alert, repositories, dashboarding, and configuration. So this is basically, and also the node, the elements around security and node management and user management. So this constitutes the smart edge, making sure that it has. So I think if you see, there needs to be a lot of let's say capabilities that needs to be embedded into that devices. So it does have it does have a kind of a elements that needs to make sure that you have the integrations done with the various ecosystem players that are there in the platform, and at the same time provide the edge computing services that are need to, let's say, process and synthesize data to drive business decisions and business outcomes. So if you move to the next slide, it actually mentions about the benefits of the edge computing for IoT. So making sure that it's cost effective. So no need to transport all the IoT data, so that you can actually cleanse the data and make sure only the required data is sent to the central system. Real-time insights. Of course, there is no latency and there's no round trip, so we can take the decisions on the edge itself. So that's basically what smart edge brings in. Local decision. So I think we can actually take those decisions. Operate reliably even if there's limited network connectivity. So this is basically like an offline mode of operation. Then security and privacy, making sure that if there's no data transported on the network, you're actually making sure that you don't expose that to malicious hackers uh, and other entities to get access to that data. So that's about the benefits of the smart edge. These are the various um, uh, use cases. So there's smart city. They're leveraging smart cities. They are leveraging fleet management, vehicle management, water processing. There's also oil rigs, oil fields as well, grid, smart grids, power grids, etc. So I think water processing plants. So there's basically a number of applications that leverage the IoT platform and the IoT services capabilities, right? So I think if you move to the next slide, and I think this is an interesting slide. It talks about the complexities that we have as part of the IoT solutions using edge computing. So growing volumes and varieties. I think if you see the sheer numbers, right, number of edges that are there actually varies in terms of what context you're running it in. So it's let's say hundreds. It could be hundreds of edges in a factory layout, in a factory setup. It could be about 10 to 20,000 in a bank branch network, or it could be 20 to 80 on a fleet of a truck, 20 to 80,000 on a fleet of trucks. So this is basically the range of the endpoints that you have, the edge devices that you have. Managing edges in the rough environments. So if it's actually deployed on, let's say, factory plants or oil rigs or pipelines where troubleshooting is challenging, so managing them is a real pain. Ensuring that the uptime and availability, right, so workloads needs to be maintained and monitored 24/7 with a high level of reliability. 100% of 100% uptime is often required. So I think if you see, the uptime and reliability requirements are quite stringent. So that is again some of the complexities that you have as part of the IT platform. Protecting sensitive data, maintaining the physical and logical security of all assets in the edge is also complex and critical. So I think, considering that it's a complex ecosystem of nodes, endpoints, central systems, your networks, I think it's also making sure that you need to protect your sensitive data. Maintaining software on the edge is also something that is one of the challenge, because you need to provide and roll out your upgrades and your security patches and your policies and whatnot on onto the endpoints, making sure that it is a foolproof process. So I think that's also something that is kind of a tricky to handle in terms of large complex platform ecosystem, and keeping up with the data flow. So the edge needs to handle huge data flows, right? So I think huge streaming data from things like your oil rigs or your hydropower plants or your fleet management solutions. So I think this basically needs to cope up with the needs of, or loads of the data that is streaming in. So these are the typical complexities that you have as part of a IoT platform that is deployed for various user scenarios. And then I'll actually then move to the next slide, which actually talks about uh, the Azure set of Azure suite, Azure IoT suite that we have. So I think Azure IoT suite is a mix of solutions and services and frameworks that you can leverage to deploy an IoT platform, an IoT solution for your customers. It's actually a pre-configured solution, so it's like out of box. A lot of heavy lifting is already done for you in terms of, let's say, some of the pre-configured AI ML machine learning algorithms. You have connectors which can actually be, let's say, deployed and configured with minimal coding. So I think a lot of it also involves low code, no code development. But if you see, I think there's a gamut of services that are shown here, be it your event processing, be it your predictive analytics, be it your data virtualization or workflow integration, or ID and identity and access management. So these are services that needs to be leveraged to actually build that IoT platform. So this is at a high level of functional breakup of the IoT suite of products. I think the pipeline is something that we've already seen, and this is another representation for Azure specific platform. So at the left, you have the IP capable devices, your sensors and your devices and your factory actuators, etc. Then they basically are ingested through a gateway, and from the gateway, from the field gateway, it comes to the cloud gateway at the center, where you are doing the device and the event processing. And that is where you have your key core platform deployed, right? So we'll have your solution portal, which will facilitate user management and device management. And then you'll have your identity and registry stores. Then you have the device state store, etc. And then the key would be your storage, of course, a data lake where all the data streaming in from various nodes is ingested and processed for finding the insights and decisions. And then you have the AI machine learning modules as well. So this is basically something that forms the IoT platform. And then that, from there on, it actually then goes to the presentation, which basically is where you do the decision making and driving the business outcome. So this is the typical IoT platform that we have, with various stages that are shown in. This is again another representation of the processing pipeline. So where you have the data ingestion, collection, ingestion, streaming, analytics, storage, and presentation. So this is basically also provides you with a level of details in terms of what services are leveraged. So collection, you'll have the IoT and the field gateway. Then for ingestion, you have the IoT hub. For streaming analytics, you have cognitive services, you have the stream analytics, and you have the machine learning services to do the to basically run on that and derive insights from it. And then that storage and analytics is then ingested into your presentation and decision and action element. So this is basically what drives the business outcome. So this is basically the IoT processing pipeline in further detail. This is again another slide which provides another let's say, details in terms of what all constitutes the various building blocks of the platform. So it actually is leveraging pre-device authentication, which is basically the leveraging the identity and access management system. Um, so it supports the MQTT and HTTP QMB protocol, the ones that connects the edge computing to the devices and the sensors. Other thing is the device SDK actually constitutes of multiple programming languages, so you can actually be able to program it using Java or C Sharp or JavaScript, and it can scale to millions of simultaneously connected devices and millions of events per second. So that is a scale that it can be configured for. So enterprise grade platform can be leveraged on different user scenarios and different scenarios that are there, as we discussed earlier. So this is basically the overall, let's say, capabilities of the platform. This is just another level of deep dive in terms of what those services are, in just as we just discussed, the IoT hub, the steam processing, the machine learning component, the data insights, etc. And these are the set of solutions and services that are provided through those Azure components. And this probably what is leveraged as part of the entire ecosystem in terms of your IoT platform. And in terms of deployment option, yes, it can be deployed. The Azure IoT platform can be deployed in public, private, or hybrid configuration. And the overall selection is based on these criteria, exactly in terms of the business needs, data sensitivity, the latency requirements, and connectivity constraints. So this basically are two or three key things that you will typically consider. I'm sure there's more to these while you're evaluating. This is probably just at a very high level, but definitely a number of parameters have to be considered in terms of why we need a or a B or a C in terms of our deployment options. So the next slide is the client benefits. So what exactly would be benefits of such a platform, which is an integrated a solution? So it definitely constitutes maximizing revenues by unleashing the value of your corporate data and exploiting the new business models, accelerate value, right? Reduce time to realize value from IoT data through pre-configured offerings and IoT expertise as well. And then it does reduce the cost, right? If you have a complete platform which is operational, which has a complete end-to-end, let's say, automation built on it, it can actually have an effect of making sure that there are very less operational overheads. The platform is intelligent enough to drive and detect the anomalies and do the corrections on some of these elements. The pricing is something that is flexible. Of course, that is something that we can actually get it based on the various services and solutions that we leverage, the deployment options, and probably also related data storage, increase, and so on and so forth. Scalability is, as I said, we can have it scaled to millions of devices and millions of events per second, and visibility and control, because I think can actually centrally, let's say, manage the devices and the users on this platform, giving it the complete control. So this is basically so I've reached the end of the presentation. I hope you found this presentation insightful and thought-provoking. These are my Twitter handles. This is my email ID. In case you have any specific queries, feel free to reach out to me. And thanks for joining in, and enjoy the rest of the event. Thank you. Bye.